Man has never stopped searching for answers to understand his own existence. Human biology is the original unknown, which continued to challenge man to discover who he is and where he came from. Scientists have long known about DNA, the building block of life, and how it contains the genetic code that informs so much of who we are. The human genome, the individual's complete set of DNA, has been considered as our own blueprint. However, there was still much left undiscovered. How the DNA coding the genes that dictate directly and invariably of what we will become remained a mystery. How these genes ultimately determine variations causing myriads of genetic conditions that have been afflicting millions of lives had remained uncertain. Because of this missing piece of knowledge, scientists all over the world work together towards a great endeavor to crack the genetic code and break what we considered as a great barrier in understanding the nature's blueprint for building a human being. Hence, paving the way for the creation of the Human Genome Project, the most ambitious undertaking in the history of biology, which mapped and sequenced approximately 3 billion base pairs of the human genome, the molecular instruction book of human life. However, as men embarked on genetic mapping and sequencing, concerns for the misuse of the genetic information emerged. With man's desire for new knowledge by breaking the genetic code, had he breached the ethical, social, and legal norms of his own existence? The idea of the HGP was first publicly advocated in the 1980s by Renato Dubecco, a scientist from Salk Institute who was investigating on cancer cells. He claimed that knowing the human genome sequence would facilitate an understanding of cancer. It was in the mid-1980s when a series of meetings were held by experts started by Dr. Sidsheimer, then by Dr. Watson, and lastly by Dr. Baldstein among others. They debated the merits of the potential project. Although the meeting concluded that the project was technically possible but very challenging, half of the experts strongly opposed the project. The oppositions argued that the project would divert resources from single investigator science and that the needed technology was not yet in place to undertake such a complex project. They further contended that mapping and sequencing the genome was a routine and monotonous task that would not attract appropriate scientific talent.
Human genome sequence. We talked about it, and it was very divisive. A lot of people said, no, it's just too big, too boring. They'd rather do science than just sort of be a technician.
There were very strong advocates and a fair amount of opposition, and I must say I was among the opponents at that time.
The project was simply an industrial scale project, perfectly technically feasible.
With significant oppositions and lukewarm support from the majority of the biologists, the project had failed to gather enough momentum. It was not until the US Department of Energy advocated for the HGP that pushed the project forward. According to the DOE, by knowing the genome sequence, it would help us understand the radiation effects in the human genome resulting from exposure to atom bombs and other aspects of energy transmission. This DOE advocacy was critical in facilitating the initial stages of the HGP. A major challenge in the creation of this project was the cost that it entailed. The proposed project had an estimated budget of $3 billion with targeted 15 years of completion. This huge budget needed substantial federal funding support for it to succeed. Another issue that the HGP was confronted with were the different perspectives that emerged from a number of philosophers, clergy, and policymakers who weighed in on the project's merit in terms of the concerning ethical, legal, and social issues. Some of the ethical, social, and legal concerns included the following: infringement of genetic privacy and confidentiality, abortion choices for unborn child with genetic defects and use of embryos for research, potential discrimination, inequality and injustice, violation of human rights. On the other hand, the Church was supportive of the Human Genome Project as expressed by Pope John Paul II on his address to the Pontifical Academy of Sciences. The Church, however, explicitly objected on the issue of abortion on any grounds. With the rising social issues, James Watson, the first director of the Human Genome Project, announced in October 1988 that a portion of the project's funding would be set aside to study such issues. The result was the creation of the National Institute of Health and Department of Energy Joint Working Group on Ethical, Legal, and Social Implications of Human Genome Research, also known as ELSI, chaired by Nancy Wexler. This group was created to address and resolve the societal issues surrounding the genome program. And on April 27, 1988, the proposed Human Genome Project had reached the Congress. A hearing was held to address public policy issues and funding for the project. Surprisingly, there was more support from the US Congress than from most of the biologists. As Honorable Ron Wyden stated in his opening speech, if NIH does not proceed with the mapping and sequencing of human genome, American science and US industries will fall behind, perhaps permanently, in the quest to better understand human diseases. And in 1990, Congress authorized the Human Genome Project. The Human Genome Project was officially launched as a joint effort of the U.S. Department of Energy and the National Institute of Health. With the support of the federal government, several private sectors had gotten involved, as well as various universities and research centers worldwide. And because of this, the Human Genome Project was dubbed as the biggest scientific collaborative project in the history of science. And due to this collaboration, new technologies were created that sped up the process of sequencing and subsequently dropped down the cost of the project. In 2000, President Clinton, together with Francis Collins, the new director of the Human Genome Project at the National Institute of Health, Craig Venter of Celera Genomics, and Ari Pachinos of the Department of Energy, announced the completion of the Human Genome Project.
We are here to celebrate the completion of the first survey of the entire human genome.
With the completion of the Human Genome Project, a database of the entire human genome sequence was established. Scientists identified the locations of many genes and learned more about their structures and organization that led to better understanding of genetic diseases and discovery of gene therapies. In the late stages of the Human Genome Project, and in the years thereafter, several important private and public spin-off projects were launched. The economic impact of the HGP was a huge success, generating $796 billion and creating 310,000 jobs. President Obama touted the project in his State of the Union address in 2013.
Every dollar we invested to map the human genome returned $140 to our economy. Every dollar.
Most importantly, the ELSI program served as an important social safeguard. It became the world's largest bioethics program and a model for other ELSI programs worldwide. ELSI provided recommendations to the Equal Employment Opportunity Commission and to Congress. It also became a vocal proponent of the following legislations. The Human Genome Project broke an enormous knowledge barrier on the key to understanding the human life. It left a legacy as the most significant scientific discovery of the 20th century and had impacted the current practice of medicine.
In the last 20 years, ever since Human Genome Project took off, we have made significant strides.
Undeniably, man had benefited a lot from breaking his genetic code. However, as man continues to discover new information and create new technologies, it is inevitable that man's ethical, social, and legal standards will always be challenged. The hope is that man may always be reminded that these technological advancements should be created and used for the greatest good.